For more than 2 decades, something has been sitting 600 meters beneath the Caribbean, waiting for a question nobody has been willing or able to answer. A robot reached it once. Its camera showed pale shapes rising from darkness, flat surfaces, straight edges, blocks that seemed to stand in rows, and massive forms disappearing beyond the vehicle's lights. Then the expedition ended. No core was drilled. No stone was lifted. No laboratory ever tested what the camera had seen. The site was left alone, and the only direct footage remained trapped in a small collection of grainy images. That is why the discovery is still dangerous. Not because it proves a lost city, but because the one piece of evidence capable of killing the mystery has never been collected. The story is often called The City Beneath the Bermuda Triangle. That title is wrong before the mystery even begins. The formations were reported off the Guanahacabayas Peninsula at the western end of Cuba, near the Yucatan Channel. Cuba's far western seafloor does not sit inside that familiar triangle. The vehicle was not an airborne drone either. It was a remotely operated underwater vehicle connected to a ship by a cable and controlled from the surface. Correcting those details does not weaken the story. It removes the mythology hiding the real problem. A professional survey found unusual geology at a depth where human construction appears almost impossible. The discovery began around 2000 and became public in 2001, when a Canadian company called Advanced Digital Communications was working with Cuban authorities. The company was led by marine engineer Paulina Zalitsky and her husband, Paul Weinsweig. Their operation was not searching for Atlantis. They were surveying deep water west of Cuba, an area crossed for centuries by ships moving between the Caribbean, the Gulf of Mexico, and the Atlantic. The original commercial interest involved underwater exploration, including the possibility of locating wrecks and valuable historic cargo. Finding one could justify years of expensive survey work. The team used side-scan sonar, one of the most important tools in seafloor exploration. A sonar device sends sound toward the bottom and measures the echo returning from each surface. Soft mud absorbs much of the sound and appears dark. Hard rock reflects more energy and appears bright. A tall object can block the sound behind it, creating an acoustic shadow. Those bright returns and dark shadows allow trained operators to recognize wrecks, boulders, ridges, pipelines, craters, and other structures even when sunlight cannot reach the seafloor. The image is not a photograph. It is a map built from reflected sound, and that difference matters enormously when geometric patterns appear. During one survey, the sonar began returning shapes that did not resemble the ordinary scattered texture expected from deep sediment. Bright areas seemed to form repeated lines. Some features looked rectangular. Others were later described as circular, pyramid-like, or arranged like roads and buildings. Reports placed the zone between roughly 600 and 750 meters below sea level and described the anomalous area as extending across several square kilometers. What remained consistent was the impression that hard features were rising above a broad, pale seafloor in patterns that looked unusually organized. A single sonar image can deceive even an experienced reader. Ship direction, instrument angle, seafloor slope, software processing, and acoustic noise can create distortions. Natural ridges can appear as walls when viewed from one side. Shadows can make rounded rocks look sharply cut. They surveyed the area again and reported that the unusual patterns remained. The repeated detections convinced them that the target was physically real, not merely a temporary glitch. But repeated sonar could only confirm that hard objects existed. If the tether became trapped or a critical system failed, the team could lose the vehicle. Even a brief inspection demanded specialized equipment, calm operations, trained technicians, and a research vessel capable of holding position far above the target. As the ROV approached the bottom, its lights revealed stone-like forms. Accounts described large, smooth blocks, some apparently stacked, and broad surfaces that looked more regular than the surrounding terrain. Zalitsky compared the scene to an urban center, but she also delivered the most important sentence in the entire case. It would be irresponsible, she warned, to say what the structures were before evidence existed. That caution is often removed from dramatic retellings. The person most closely associated with the discovery did not announce Atlantis. She described an extraordinary visual impression and admitted that appearance alone could not establish origin. The video created a powerful illusion of certainty because cameras feel more trustworthy than sonar. But a deep-sea camera can be misleading in different ways. There is no sunlight to reveal natural color or wide distance. The ROV's lamps illuminate only a narrow cone, flattening texture and throwing hard shadows. Sediment hides the base of objects. Scale can be difficult to judge unless the vehicle carries lasers or another reliable reference. A natural rock face viewed through murky water may look like a wall. A broken slab may look cut because the camera never sees the full fracture. This is the point where the lost city theory collided with the depth. During the last ice age, global sea level dropped because enormous volumes of water were locked inside glaciers. At the lowest point, the ocean stood about 120 meters below its present level. But the Cuban formations are reported at roughly 600 to 750 meters. Even at the coldest recent glacial maximum, the target would still have been around 500 meters or more beneath the ocean. Sea level change alone, therefore, cannot place a 6,000-year-old city at that depth. Something much larger would have to happen. Either the seafloor sank hundreds of meters after construction, the proposed structures are vastly older than known urban civilization, the reported depth is seriously wrong, or the shapes were never buildings at all. Each possibility creates its own problem. The depth was measured during professional marine operations and has been repeated consistently. A city old enough to predate known settlement in the Americas by tens of thousands of years would require evidence far beyond ambiguous video. Sudden regional subsidence of hundreds of meters would leave a geological record that scientists should be able to identify. Manuel Itoral de Vinent, a respected Cuban geologist connected with the National Museum of Natural History, joined the investigation because geology had to answer this challenge. He described the formations as extremely unusual and acknowledged that some shapes were difficult to explain from the available images. Yet he also pointed out that sinking land from the surface to the reported depth would require an immense period under plausible tectonic rates, perhaps at least tens of thousands of years. The claim of a city only several thousand years old did not fit. Before archaeology could enter the argument, geology demanded a mechanism capable of lowering an entire landscape far below the deepest ice age shoreline. The western Cuban region is not geologically simple. Cuba formed through the movement, collision, and assembly of crustal pieces around the Caribbean and North American plates. Western Cuba contains thick sequences of limestone, sandstone, and other sedimentary rocks, along with structures created by faults, folding, erosion, and ancient tectonic activity. Or, the seafloor toward the Yucatan Channel includes slopes where blocks can fracture, slide, rotate, and settle. None of that automatically explains the reported pattern. It does show that natural processes have millions of years and enormous forces available to produce shapes that may look designed during a short robotic inspection. Rock often breaks along joints, fractures where there has been little visible movement. Stress can organize those fractures into repeated sets. Bedding planes can divide sedimentary rock into flat slabs. Faults can create long straight boundaries. Chemical erosion can widen cracks. Gravity can pull blocks downslope, leaving rows, terraces, and sharp faces. Underwater landslides can move huge pieces while preserving parts of their original layers. When sediment later settles around them, only their flat tops and edges may remain visible. A camera then arrives from one direction, and a geological collapse begins to resemble a ruined city. Nature has created many famous formations that were initially mistaken for architecture. Basalt can cool into polygonal columns so regular that they resemble engineered pillars. Sandstone can fracture into blocks with near right angles. Limestone pavements form straight cracks in rectangular slabs. Underwater sites, such as Japan's Yonaguni Monument, continue to divide observers because broad terraces and sharp steps can emerge from naturally jointed rock, even if humans may later use or alter the landscape. Straight lines are evidence of geometry. They are not, by themselves, evidence of architects. The Cuban case is harder because researchers do not possess a sample from the target. A piece of rock could answer several questions immediately. Thin sections viewed under a microscope would reveal minerals and texture. Geochemical analysis could compare the material with known Cuban or regional formations. Microscopic surfaces might show natural fracture patterns, biological erosion, or repeated tool marks. Sediment trapped around the blocks could indicate when they were exposed or buried. Drilling beneath a feature could reveal whether it continues into bedrock. If a supposed block is attached to the layer below, it was not transported and placed like masonry. Dating would be more complicated than headlines suggest. Most rocks cannot be dated simply by placing them in a machine and asking when a wall was built. The minerals may reveal when the original rock formed millions of years ago, not when it fractured or was moved. Archaeologists would search for material associated with human activity: charcoal, shell, bone, worked objects, or sediment deposited during construction. They would examine weathering and biological growth. A real city should produce more than big stones. It should leave roads with repeated construction, debris, tools, pottery, food remains, hearths, burials, or patterns showing that surfaces were deliberately modified. None of those signs has been documented at the Cuban site. The sonar and video reports show anomalies, not artifacts. No inscription has been recovered. No ceramic fragment has been filmed. No doorway has been entered. No wall has been excavated to show courses continuing beneath sediment. There are no measured tool marks available in a published archaeological study. Images circulated online often include dramatic computer artwork that is not original expedition footage. Some show perfect pyramids and streets illuminated in blue water. Those images have shaped public memory more strongly than the limited sonar records that started the mystery. The absence of artifacts does not prove a natural origin because the site has barely been investigated. A short ROV visit could easily miss small objects buried under sediment. Deep currents may scatter light materials, Marine organisms and mineral deposits can cover surfaces, but absence changes the balance of probability. Archaeological claims grow stronger when independent evidence converges. A formation that looks like a wall is interesting. A wall containing mortar, tools, cultural debris, and a datable occupation layer is archaeology. After more than 20 years, the Cuban formation remains trapped at the first stage, a shape that resembles something familiar. The public story changed rapidly after the announcement. References to pyramids appeared. The estimated age of 6,000 years circulated, even though no sample had been dated. Atlantis entered the discussion despite the absence of any connection to Plato's story. Some accounts link the site to Maya civilization, although the depth and chronology made that difficult. Others claimed authorities had hidden the discovery. Every new version added certainty, while the physical evidence remained exactly the same. Sonar became a detailed city map. A brief ROV video became an expedition through the streets. A geological anomaly became proof that historians had concealed an advanced civilization. The Bermuda Triangle label was added for the same reason. It gives viewers an instantly recognizable mystery, even though the site lies off western Cuba rather than inside the usual Florida, Bermuda, Puerto Rico outline. The triangle itself has no official boundary, and American maritime agencies do not recognize it as a special region where unexplained losses happen more frequently. But linking the Cuban formations to it creates a story containing two mysteries instead of one. The cost is accuracy. The robot explored a deep Caribbean site near Cuba, not a supernatural zone with an official border. There's also confusion over the word drone. Modern audiences imagine an autonomous machine programmed to fly or swim through unknown terrain. The 2001 vehicle was more likely a conventional tethered ROV controlled by operators aboard the ship. That distinction matters because a tether limits movement and can prevent the vehicle from entering tight spaces. The pilot must protect the cable from rocks. The robot's range depends on the ship's position, currents, visibility, and available bottom time. The footage was not a complete survey of every object. It was a narrow human-guided pass through a difficult environment. Why did researchers not return with better equipment? A ship capable of deep-sea operations can cost tens of thousands of dollars per day before specialized vehicles, technicians, permits, insurance, fuel, and laboratory work are included. Mapping several square kilometers at high resolution would require repeated passes. Sampling would require a manipulator arm, coring system, or drilling equipment. If the first attempt failed because a block was too hard or the sediment too deep, the team would need another dive. One short expedition could consume a budget larger than many archaeological projects receive in years. Politics and access likely made the challenge harder. Research in Cuban waters requires Cuban authorization, and international partnerships involving Cuba have long faced financial, diplomatic, and logistical obstacles. Equipment owners need contracts, export approvals, safe ports, and confidence that a project can be completed. A sensational news story can attract attention without attracting a government agency willing to finance weeks at sea. Treasure hunting companies need a potential commercial return. Universities need a clear scientific proposal and peer-reviewed support. The Cuban anomaly occupied an awkward middle ground, too expensive for curiosity, too uncertain for archaeology, and too scientifically weak for an extraordinary claim. A larger follow-up expedition was discussed in the early 2000s, but the decisive sampling campaign never happened. As years passed, technology improved while the case became colder. Original equipment aged, companies changed, researchers moved on. Raw navigation records, unprocessed sonar files, calibration information, and exact coordinates may not have remained widely available to independent scientists. Without those data, a new team could not simply download the old survey and continue. It would need to relocate the target, remap the seabed, verify the reported shapes, and begin almost from the start. That makes the next expedition both harder and valuable. Multi-beam sonar could create a precise three-dimensional bathymetric map. Synthetic aperture sonar could reveal smaller features over wide areas. An autonomous underwater vehicle could fly close to the bottom without a surface tether, following a programmed grid. Photogrammetry could combine thousands of overlapping images into a detailed three-dimensional model. ROVs could then visit selected targets, clean small areas, measure surfaces with lasers, and retrieve controlled samples. Every step would be recorded with coordinates, so the geometry could be tested rather than described through impressions. Artificial intelligence could help, but it could also make the mystery worse. Machine learning systems can classify sonar textures, detect edges, compare repeated shapes, and identify areas that differ from known natural terrain. Yet a model trained mainly on shipwrecks, pipelines, and modern debris may label unfamiliar geology as artificial. Deep sea data contain noise, shadows, and distortions. AI can find patterns that humans overlook, but it can also turn random repetition into false confidence. The final decision still requires physical geology and archaeology. No algorithm can determine whether a rock was built into a wall if nobody examines the rock. Suppose a new expedition found that the blocks are limestone attached to the underlying formation. The mystery would not become worthless. Scientists would gain a rare view of how tectonic stress, mass movement, and erosion created organized-looking terrain on the deep seafloor. The site could improve sonar interpretation by showing how natural features imitate architecture. That knowledge would help archaeologists avoid false discoveries elsewhere and help engineers map hazards around pipelines and cables. A natural explanation would solve one question while opening another. What exact sequence of geological events produced such striking geometry? Now, suppose samples revealed something genuinely artificial. The consequences would be enormous, but the evidence threshold would become even higher. Researchers would need multiple laboratories to confirm the material. They would need undisturbed cultural layers and secure dates. Independent teams would have to rule out modern dumping, ship cargo, military construction, or industrial debris. Geological studies would need to explain how the site reached its present depth. Archaeologists would compare any artifacts with known Caribbean cultures. One carved stone would not prove a city. A complete human-built complex at 600 meters would demand a rewrite of both archaeology and regional geology. The people of the Caribbean is already an active scientific field built from archaeology, ancient DNA, linguistics, and environmental records. Known settlement of Cuba occurred thousands of years ago, followed by later migrations from the Americas. Those communities were skilled navigators, fishers, farmers, and craftspeople, but no accepted evidence places an urban stone civilization in the region tens of thousands of years ago. If the underwater formation were built when the land stood near sea level, it would either require extraordinary subsidence after a much later settlement, or human activity far earlier than established Caribbean archaeology. Both possibilities are testable, and neither can be accepted from shapes alone. The strongest argument against a city is therefore not that ancient people were incapable. It is that a human explanation must solve several independent problems at once. It must explain the depth. It must establish the age. It must identify a construction method. It must show cultural material. It must connect the site to a population. And it must survive geological analysis, demonstrating that natural fractures and landslides cannot produce the pattern. The natural explanation has fewer requirements. Rock already exists at that depth, and known processes can create blocks and lines. That does not prove nature made this particular formation, but it gives nature the stronger starting position. The strongest argument for returning is equally simple. The existing evidence is too incomplete for a final verdict. Litoral de Venant did not dismiss every image as ordinary. Early experts repeatedly described the formations as peculiar. Zalitsky's caution was not a retraction. It was a request for evidence. Sonar detected hard relief, and the ROV filmed real stone-like forms. A serious investigation should not be confused with belief in Atlantis. Science often begins when an observation does not fit comfortably into the first explanation. The correct response is not to announce a city or laugh at the anomaly. It is to measure more. For over 20 years, the debate has survived because each side holds only part of what it needs. Supporters have shapes without artifacts. Skeptics have plausible geology without samples from the exact structures. The discovery team had direct access, but limited follow-up. Later commentators have more powerful technology, but no expedition. The site exists in a gap between an image and an object. As long as that gap remains, certainty in either direction is manufactured. This is also why the story feels more unsettling now than it did in 2001. Humanity has mapped planets, landed robots on Mars, photographed a black hole's shadow, and returned samples from an asteroid. Yet a formation on our own planet, reachable by existing deep-sea vehicles, remains essentially untested. The barrier is not impossible engineering. It is a priority. Research vessels are limited. Governments and institutions choose projects with clearer scientific returns. The ocean contains millions of unknown features, and one ambiguous site must compete against climate research, ecosystems, earthquakes, resources, and hazards. Mystery alone does not guarantee ship time. If a mission returned today, the first discovery might be that the old story had exaggerated the pattern. High-resolution mapping could reveal that apparently separate blocks are connected ridges. The famous right angles could soften into irregular fractures when viewed from above. Features called pyramids might become ordinary mounds. That possibility is exactly why a new survey matters. Better data should be allowed to destroy the mystery if the mystery is an artifact of low resolution. The opposite could also happen. A three-dimensional model might show repeated dimensions, parallel walls, entrances, and layered construction, impossible to explain as random jointing. Sampling could reveal stone transported from another location. Sediment beneath the blocks could contain organic material linked to human activity. Every extraordinary discovery begins as an observation that experts initially struggle to classify. But it becomes science only when evidence grows more precise than the story told about it. Until then, the title needs one final correction. The robot did not discover a city. It discovered formations that looked city-like to the people watching the screen. That difference is the entire case. City is an interpretation. Formation is an observation. One word assumes builders, the other leaves the origin open. Responsible storytelling should preserve that open space because it is where the real suspense lives. The footage from 2001 cannot tell us whether a hand ever touched those blocks. Sonar cannot tell us whether a straight edge is a wall or a fracture. The depth cannot disprove human construction, but it makes it extraordinarily difficult. Geological processes can produce order, but no published sample has tied a specific process to every feature in the video. The evidence does not support Atlantis, a Maya city, a Bermuda Triangle secret, or a government cover-up. It supports one conclusion only. A strange, deep-sea site was found, briefly filmed, and never investigated well enough to explain. Somewhere west of Cuba, darkness still covers the same pale surfaces. Sediment continues to move around them. Marine life grows, dies, and settles. Currents pass through gaps that may be corridors or cracks. The stones do not care which story humans choose. They carry a physical answer in their minerals, fractures, and relationship to the bedrock. A small sample, lifted through 600 meters of water and placed beneath a microscope, could end decades of speculation. But no sample has arrived. That is the final finding, and it is more powerful than any computer-generated image of a drowned city. The most important object in the entire mystery is not one of the enormous blocks. It is the missing piece of rock that nobody brought back. Until an expedition collects it, the Cuban seafloor will remain a test of how humans react to uncertainty. We see straight lines and imagine builders. We see impossible depths and imagine catastrophe. We see silence after one expedition and imagine secrecy. The ocean offers a shape, and the mind completes the city. So what did the robot find? It found enough geometry to force another look, but not enough evidence to justify a conclusion. It found a place where geology can imitate archaeology, or where archaeology could be hiding inside geology. Found a mystery that has survived not because the evidence is overwhelming, but because the evidence stopped too soon. And the question waiting at the bottom is no longer whether Atlantis lies near Cuba. It is whether anyone will return before 20 more years pass, collect the one sample that matters, and finally discover whether those straight edges were made by human hands or by an ocean that has always been better at creating illusions than we are at recognizing them.